Okay, Mr. Rowe here, going to do problems number 1 and 2, page 42. For the homework, doing a video submission on the home board. This is where I'm going to be mostly doing most of the homework, since this is the first one. Page 42. Your problems are number 1 through 6. That is A and B included. So we're going to start off with number 1. Number 1, I have my book here. Says that Heather and Matthew walk with an average velocity of 0.98 meters per second eastward. So that is my average velocity equals 0.9. Let's go back. This is my G step on my first problem, number 1. Okay, that looks good on the video. Eastward, 0.98 meters per second. Eastward, the capital E stands for eastward. And if it takes them 34 minutes to walk to the store, what is their displacement? So you have delta T, or change in time. Final time would be 34 minutes. Okay, so delta T would be 34 minutes. Remember, delta anything, in this case it's going to be T, is time final minus time. T stands for the time, so I'll erase that and put initial. So the initial time, we had final time 34 minutes. Multiply that by 60 seconds per 1 minute. The minutes cancel. And now a simple calculation of 34 times 60. Your time should now equal, put a 0 at the end, the unit of seconds. 6 times 4 is 24. 6 times 3 is 18, plus 2 is 2,040 seconds. So delta T is 2,040 seconds. My average velocity is 0.98 meters per second eastward. Okay. What is their displacement? So, the unknown will be delta x, which, according to this up here, is also equal to x final minus x initial. This will be explained in class as well. So the third step of the guess method is the E. Let's go over this again. Givens, unknown, equation, and the next step I'll tell you when we get there. The equation for V, for average velocity, where V is velocity, AVG is average, and this would be V sub average because it is a subscript, equals delta x, or displacement, distance, divided by change in time. So change in distance, or displacement, divided by change in time. Next step will be the substitution step. That's the first S. Okay, we're going to go a little bit more on this and expand this to what we actually need to find. They want me to find delta x. So delta x is on top. We need to get the delta t away from this side of the equal sign. So you multiply both sides by delta t, and now you have delta x by itself on this side of the equation. We can flip it, just change the x to this side of the equal sign, and that will be the same as v average times the change in time. All right, now for the substitution. I did this on the equation step so that I don't have to take up a lot of room with the S stage. It's already usually going to be a little bit longer on the paper than most. So they want me to find delta x. Delta x equals, it says over here V average. Well, up here we have V average at 0.98 meters per second eastward. And it says times delta t. So delta t we found to be 2,040 seconds. So times 2040 seconds. Okay, at this point there's also something else you can do to help with units. You can go ahead and cancel the two s's because this is s over 1, which anything over 1 is just the anything. In this case it's s. The s gets canceled because it is on the bottom, and a cross cancellation occurs when you have this. Actually, this can also be, and should probably be for the first couple of problems, written as such. So I'm going to go ahead and start at this point writing this. So a bottom s and a top s will cancel. Now you have meters is the only unit. And what does this come out to? 0.98. Delta x equals 0.98 times 2,040. That's going to come out to 1999 should be 2. And that would be in meters, because that's the only thing that we have, and it would be meters east. Drop all the units back down. Okay, so 1,999. That's pretty close to 2,000. Let's go over the significant figure rule. I have 2 significant digits in this number. I have 2 significant given numbers. So my answer needs to also be in 2 significant digits. 2 significant digits would be right here. For this step, look at the number right next to it, the 9. If it's 5 or greater, raise the next number up. Well, a 9 is going to go to a 10, which you carry 1 over here, so that would be 20. So delta x equals 2,000 meters. But that's one significant value. 2 is, these are all zeros. Those don't count. So you need to move this to 2 to scientific notation, where that will equal 2.0, because this is 2 significant figures if it's a point and a 0. And you moved it 1, 2, 3 places. You have a decimal here, and you've moved it 3 places to get there. Times 10 to the 3 meters. Okay, now the book gives us the answer in kilometers, which times 10 to the 3 meter is technically kilometers. They don't give us any kilometers up here. I will accept 2,000 meters, 2 times 10 to the 3 meter, or delta x equals 2.0 kilometer. Now, if you see the times 10 to the 3 meters, that's going to automatically mean you can change that to kilometer. Problem number 1 complete.